two things are coming. What is a sequence and what is a series? Because the chapter name, if we will not be able to understand what we will be going to do. So sequence. See, any infinite terms are in whatever way. Like I'm writing one sequence as 1, then again 1, then 1 plus 1, two previous terms I'm adding. 1 plus 2, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, and so on. This is infinite. This will be containing infinite terms. So this can be said as a sequence. Now, a series. Sequence must be containing infinite terms. What is a series? It could be containing finite or infinite terms. It could contain any. Like one simple thing, sigma a n. N is 1 to whatever. It could go till k or so. This is a series. Like I'm writing one example. One, 3, 5, 7. I'm going to stop it. And it could go forward also. It is a series. It is containing finite terms with a definite pattern. So that is there. Now, in this condition, I'm giving one good example, and this is mainly the part of your studies. AN is given to us. AN is given 2n plus 5. Write the first, okay, 3 terms. Four, okay. We are writing first 4 terms. So A1, when you will put n as 1, that will be said as the first term. So it will be 2 into 1 plus 5. So it will be 7. Now we are going to put A2. This will be the second term. So 2 into, in place of n, we will be going to put 2 plus 5. So 4 plus 5, it will be 9. Now A3, 2 into 3, and I put now 3 plus 5, 11. Last A4, 2 into 4 plus 5, 13. So A1, A2, A3, A4, and so on. But we were supposed to calculate only first four terms. So first is 7, then 9, then 11, then 13. This is the sequence which we have prepared as per asked question. So hope you are able to understand when they are asking this kind of questions. What we need to do, we need to put the values whatever are given, and on the basis of that we will be able to get the results. Easily you all will be able to get the result in this situation, and that results will be helping you to solve the questions. Now one more question with the same manner I am going to do. This one I'm taking question number 5 from exercise 9.1. An is equals to minus 1 to the power n minus 1, 5 to the power n plus 1. Okay, in this case, we are writing first three terms of this series. So A1 will be minus 1 to the power 1 minus 1, and I need to put as 1 plus 1. It will be minus 1 to the power 0, 5 to the power 2. Minus 1 to the power 0 will be 1 into 25. So it will be 25. Now A2. In place of n, I need to put 2. So it will be minus 1 to the power 2 minus 1. 5 to the power 2 plus 1. So it will be minus 1 to the power 1, 5 to the power 3. Negative to the power odd. Negative to the power odd will be negative. Negative to the power odd will be always negative into 125. So it will be minus 125. Next is third term I am calculating minus 1 to the power 3 minus 1. 5 to the power 3 plus 1. Minus 1 to the power 2, 5 to the power 4. Now negative to the power even. Negative to the power even will be positive into 625. So now let us write the terms. It is 25 minus 125, 625. We were supposed to calculate three terms. As per the question, it is said we need to write the first 5 terms. But while solving, I said for you 3 terms. If more you are supposed to calculate, that is easily you will be able to do the question. Only the thing is you must be able to understand it. Sometimes some of the questions they used to give and they say us to calculate some specific term. Like I'm taking question number 8. It is an is equals to n to the power 2 upon 2 to the power n. We need to calculate A7. A7 means n we need to put as 7. So A7 is equals to n is 7 to power 2 upon 2 to the power 7. 7 to power 2 will be 49. 2 to the power 7. 128. So likewise, we could do this also. I suppose it is easy. Very simple and very important questions, but we need to practice them. Next thing now we are going to do. This I'm taking question number 11. It is A1 equals to 3. An is equals to 3 times A n minus 1 plus 2. N is greater than 1. Means we cannot put n1. We will be putting n more than 1. So I'm putting n as 2. It is greater than 1. We can see easily. So A2 will be 3 times A2 minus 1 plus 2. That is 3 times A1 plus 2. And the value of A1 is 3. So 3 into 3 plus 2. It will be 9 plus 2 or 11. We need to calculate 5 terms. Again, I'm calculating 3 with that. You will be able to understand it. Now put n equals to 3. A3 will be equals to 3 times A3 minus 1. And I'm putting 3 now, plus 2. So it will be 3 times A2 plus 2. Now put A2. A2 is over here. So it will be 3 into 11 plus 2. 33 plus 2. That is 35. It is A3. So we have got the sequence, that is first term is 3, second term is 11, third term is 35, and so on. So this is said as the sequence. I have written the first 3 terms, but in the question they might ask for more also. As per NCRT, they are writing first 5 terms of this sequence. Now 14th question I'm doing. It is the Fibonacci. Fibonacci sequence is defined by A1 equals to A2 equals to 1. An is equals to An minus 1 plus An minus 2. N must be put greater than 2. This thing is the most important thing. We need to put n greater than 2. So when we will be able to remember this, we will be easily able to do the question. So put n is equals to 3. We need to put n greater than 2. So I am putting 3. A3 is equals to A3 minus 1 plus A3 minus 2. That is A2 plus A1. The value of A2 is 1 and A1 is also 1. So A3 is coming 2. Now next, put n equals to 4. A4 is equals to A4 minus 1 plus A4 minus 2. That is A3 plus A2. The value of A3 is 2 and A2 is 1. It becomes 3. Now next, put n is equals to 5. A5 is equals to A5 minus 1 plus A5 minus 2. That is A4 plus A3. The value of A4 is 3 and the value of A3 is 2. It becomes 5. Next, put n is equals to 6. A6 will be A6 minus 1 plus A6 minus 2. It will be A5 plus A4. The value of A5 is, from the previous term, it is 5. And the value of A4 is 3. It becomes 8. So we have got the overall sequence, that is first term was 1, second term is again 1, and then third term is coming 2, then 3, then 5, then 8, 2, then 3, then 5, then 8, and so on. See, this is Fibonacci. Fibonacci is just, I was explaining you in the beginning, this sequence. This is said as Fibonacci. Now see, further again is said find, from the same question it is, an plus 1 upon an. So n we need to put 1, 2, 3, 4, and 5. So put n equals to 1. It will become a1 plus 1 upon a1. That implies a2 upon a1. The value of a2 and a1 both are 1. So we are getting it as 1. Next, put n equals to 2. It will be a2 plus 1 upon a2. That means a3 upon a2. The value of a3, the value of a3 from the sequence 2 upon a2 is 1. So this implies it is 2. One more I am calculating. Put n equals to 3. It will be a3 plus 1 upon a3. That means a4 upon a3. The value of a4 is 3 upon 2. So we are getting 1, 2, 3 by 2. Further, if I want to write, then directly I can write 5 by 3. Successor upon predecessor, it is going 8 by 5. See, this term next time will be coming down. Let me show you how it is going. This is coming down. This comes down. And next term comes up. If I need to write next, that will be upon 8. And numerator will be 8 plus 5, 13. Next term upon 13, and numerator will be 13 plus 8. 8 this one, 13 this one. 21. But when you need to make, you need to show all the steps. So I think now you are able to understand, yes, what is this first exercise? And I suppose you all will be able to do. Right now, we are making all the sequences. Why we are making sequences? Why I'm saying it's sequence? Because this is containing infinite number of terms. So we are able to understand this all. And one new thing which we have studied, because this rest all the things were same as we were doing in class 10th also. But this Fibonacci is one of the new thing, and the meaning of sequence and series getting is class 11th thing. Rest all is of class 10th. This is class 11th thing. So it is important, and I suppose you all will be able to think about it. You will see we need to start our next topic of the sequence and series, that is said as arithmetic progressions. Yesterday we have done how to calculate the next few terms. If the nth term is given in a definite pattern, it was given. So using different techniques, we were able to calculate the different terms of the sequence. Now today we need to start arithmetic progressions. So arithmetic progression, first of all, definition. Arithmetic progression is the list of the numbers. Arithmetic progressions is the list of numbers in which successor term is obtained by adding a constant term to the preceding term. Like first term is A, then next term we are adding a constant term to the preceding term. So it will be A plus D. If again I'm adding D, it will be A plus 2D, A plus 3D, A plus 4D, and so on. This is said as the arithmetic progression AP. For example, some of the examples I'm trying to give you: 2 plus 3, I'm adding, it will become 5, plus 3, I'm adding, it will become 8, plus 3, I'm adding, it will become 11, and so on. This is said as an AP. So we have got arithmetic progression. Now, different examples we could give. One more I'm giving you. 15. Now, minus 2 we are adding. So 13, 11, 9, 7, 5, 3, 1, minus 1, minus 3, and so on. So this is also one of the arithmetic progression. I was writing number of terms because I was planning to go to the negative terms also. But this all was in class 10th also, so we are knowing about it very much. Now, if I need to calculate the nth term of an AP, an, see better, we are doing question number 5 in this. In an AP, pth term is 1 upon q. Pth term of this AP is 1 upon q, and p term means a plus p minus 1 into difference t is equals to 1 upon q. Cross multiply AP, sorry, AQ, my mistake, plus PQD minus QD equals to 1. Next is qth term 1 upon p. A plus q minus 1 into difference d equals to 1 upon p. AP plus PQD minus PD equals to 1. This is equation 2. Now I'm solving equation 1 and 2. So equation 1 is AQ plus PQD minus QD equals to 1, and another is AP plus PQD minus PD equals to 1. I'm going to subtract. It will get cancelled, it will get cancelled. AQ minus AP equals to, this is going on other side, so on left hand side it is negative, other side it will be positive. QD, this is positive on this side, other side it will be negative. PD. A I am taking common, Q minus P. D I am taking common, Q minus P. Now in the question it is given as P is not equals to Q. So P is not equals to Q means this 2 will get cancelled. A is coming equals to D. The value of A and D are equal. Now we are asked to find the sum of PQ terms. Sorry, first of all, let me put in one. So AQ plus PQD minus QD, I am writing A equals to 1. So AQ to AQ will get cancelled. D is coming 1 upon PQ. When D is coming 1 upon PQ, D is equals to A, therefore A is also 1 upon PQ. We have got A and D as same. Now we need to find SPQ. So we know that Sn is equals to n upon 2a plus n minus 1 into difference t. Now it is said us to find the value of SPQ. So it will be PQ by 2a. The value of a is 1 upon PQ plus n is PQ minus 1 into difference is again 1 upon PQ. PQ by 2 into 1 upon PQ. What is left? 2 plus PQ minus 1. 1 upon 2 PQ plus 1. This only was the target to prove, hence proved. So we are able to see one of the very good and important question, important for the examination point of view also. So must practice it once, then only you will be able to understand, because it's not very direct and very simple question. Now I think I should do question number 9. In between whatever questions are given that are very simple. But you must try. If you will not be able to do, I'll solve them also. The sum of n terms of two APs are in the ratios. Means sum of n term upon another APs as n dash I am making. It is given us their sum is 5n plus 4 upon 9n plus 6. This is the sum of n terms of two APs, and we need to calculate the ratio of their 18 terms. A18 upon A18 dash equals to question. Now this will help us to simplify. But first of all, I'm taking the main part. Sn can be written as n upon 2a plus n minus 1 into difference t, n by 2a dash plus n minus 1 into t dash. It comes 2a plus n minus 1 into difference t upon 2a dash plus n minus 1 d dash. Now what we need to calculate, we need to go towards that also. So see, A18 is a plus 18 minus 1 into difference d upon a dash plus 18 minus 1 into d dash. Try to notice a point over here. It is a, and in this case it is 2a. So numerator and denominator must be multiplied by 2. It will become 2a plus 18 minus 1 17 to 34t 2a dash plus 34 d dash. Now see, when we will compare, because we need to calculate this, it means on comparing n minus 1 must be 34. N minus 1 is the coefficient of d. Over here, the coefficient of d is 34. So n minus 1 must be 34. N must be 35. It means put n is equals to 35. So it will be 2a plus n is 35 minus 1 into difference d upon 2a dash plus 35 minus 1 d dash is equals to 5 into 35 plus 4 upon 9 into 35 plus 6. So it will be now LHS also I need to solve 2a plus 34d upon 2a dash plus 34d dash will be equals to. Now 2 I'm taking common, so it will be a plus 17d upon 2 a dash plus 17d dash equals to 179 upon 321. 2 to cancel. This could be written as A18 upon A18 dash is equals to 179 upon 321. This is the answer. So I think now you are able to understand this question. It's really a wonderful, very good question and important. Major part is this. You can take screenshot also, then calculation part is left. Now I'm taking question number 10. See what is said in question number 10. Listen carefully. If the sum of P terms of an AP is equals to sum of Q terms of an AP. See, sum of P terms of an AP is equals to sum of Q terms of the same AP. SP is equals to SQ. If the sum of P terms of an AP is equals to sum of Q terms of the AP, then find the sum of first P plus Q terms. Now SP means, try to see P by 2, 2A plus P minus 1 into difference T. SQ means Q by 2, 2A plus Q minus 1 into difference T. This 2 to this 2 will get cancelled. Now P I'm taking inside 2AP plus P square D minus PD is equals to 2AQ plus Q square D minus QD. Keep practicing these all the questions. Monday I'm going to take a test of AP. Keep in mind this thing also. 2AP minus 2AQ plus P square D minus Q square D minus PD plus QD equals to 0. 2A P minus Q plus D P square minus Q square minus D P minus Q equals to 0. Now, one more step I'm taking. 2A P minus Q plus, I'm taking D common. P square minus Q square can be written as P minus Q into P plus Q in minus P minus Q. I've taken D as common equals to 0. Now next step 2A, and this is just I'm taking the steps so that you must be able to understand. P minus Q I'm taking common. P plus Q minus 1 into difference T equals to 0. Now I'm taking P minus Q common. What is left? 2A plus P plus Q minus 1 into difference T equals to 0. If I want to take this term on the other side, it will be 2A plus P plus Q minus 1 into difference T equals to 0. Now we have got this much. Now our task is to calculate the sum of P plus Q terms. S P plus Q equals to, when we are talking about Sn, first of all I'm writing that Sn is equals to n by 2, 2A plus n minus 1 into difference T. Plus P plus Q is P plus Q by 2, 2A plus P plus Q minus 1 into difference T. Now see, from equation 1, see 2A plus P plus Q minus 1 into difference T has got value as 0. So result is coming 0. calculation part is from here. See this question once, it's important. Prameet, 1, 2, 3, 4, 5. We are going to insert 5 numbers between 8 and 26 such that the resulting sequence must be an arithmetic progression. So first term I could say A, next term will be A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, A plus 6D. A is equals to 8 and A plus 6D equals to 26. That is 8 plus 6D equals to 26. 6D equals to 26 minus 8. 6D equals to 18. D is equals to 3. Now, we need to calculate A plus D, that is 8 plus 3, 11. A plus 2D, 8 plus 2 into 3, 14. A plus 3D, 8 plus 3 into 3, 17. A plus 4D, 8 plus 4 into 3, A plus 5D, 8 plus 5 into 3. So the terms which we were supposed to insert are 11, 14, 17, 20, and 23. These are the 5 terms which we were supposed to insert between 8 and 26 such that the resulting sequence must remain an arithmetic progression. Now keep in mind when you are going to get 1-marker questions in the exam, in that cases, this question becomes very important because in place of writing 5 terms, they may give us write 2 terms between this and this. So they will make the questions more smart. But it is up to you how much practice. 3 terms A, sum of first Q terms is B, sum of first R terms is C. We need to prove that A upon P Q minus R plus P upon Q R minus P plus C upon R P minus Q equals to 0. This we need to prove. Now see, first part I'm showing you. With that, I think you will be able to do each and everything. What is given to us? We have been given sum of first P terms is A. Since we have got one identity, Sn is equals to n upon 2a plus n minus 1 into difference t. Now see, this a and this a should not become same. So we are supposing first term is capital A. Just the symbol, looking symbol must be changed. And common difference must be D. So SP will be P by 2 2A plus P minus 1 into difference D equals to A. Now, as per the proving condition, what I am finding with A, I want P in division. So divide both the sides by P. So it will become P upon P into 2, 2A plus P minus 1 into difference T equals to A upon P, and multiply by Q minus R. Again, it is on both the sides. So Q minus R, Q minus R. Now see, this whole term and this whole is same. This P to this P will get cancelled. Now what I could write, A upon P, Q minus R is 1 by 2 to AQ plus PQD minus QD minus 2AR minus PRD plus RD. Sorry, D is capital. I must write it in a proper way. 1 by 2, 2A plus PQD minus QD minus 2AR minus PRD plus RD equals to A upon P Q minus R. This I am saying equation 1. Now for second equation, I'll take one step, then I'll tell you what has to be done. Now see, SQ is B. SQ is B. SQ will be Q by 2, 2A plus Q minus 1 into difference D equals to B. Now again we will see. B is divided by Q. So divide both the sides by Q. Divide by Q and multiply by R minus P. R minus P. So on both the sides, we need to multiply by Q, divide by Q and multiply by R minus P. So it will be again same, like we were dividing by P and multiplying by Q minus R. Likewise, this will be giving us second equation. Same ways, we will be making third equation, and then we will add equation 1, 2, and 3. Whole LHS, there are three things. When we will add, 1 by 2 will be common and rest all the terms will cancel. And you will be getting A upon PQ minus R, then B upon Q R minus P plus C upon R P minus Q as 0. We will be getting it, the sum as 0. So I think you will be able to do this. Now please try to solve this question. Now I'm going to take next question. This I suppose you all will be able to do easily. Now I'm taking question number 12. This question number 12 is the ratio of the sum of m terms, means I could say it as Sm upon Sn. The sum of m terms and sum of n terms. The ratio of the sum of m terms to the sum of n terms of the AP is m square upon n square. Show that the ratio am upon an equals to question mark, or we need to prove something. So to prove, first of all, I have written simply the question. Then we will see what best I could do. So from the given condition, I'm taking the step. Sm can be written as m upon 2a plus m minus 1 into difference t. Sn will be n by 2a plus n minus 1 into difference t equals to. Now see, divide by 2. Now we are taking this m to m, one term cancel. This n to n term cancel. Now cross multiply. 2a plus m minus 1 into difference t into m is equals to m into 2a plus n minus 1 into difference d. Let us open the bracket. It will become 2an plus m and d minus n d equals to, now m is going inside, 2am plus m and d minus m d. Now it becomes 2an minus 2am is equals to nd minus md. I can take 2a common, it will become n minus m. Now d common, n minus m. N minus m to n minus m cancel. So 2a is equals to d. Now this is a very great thing we have got, that 2a is equals to d. Now our task is to find AM upon AN. So let us write this AM upon AN. AM upon AN is question mark. So AM, formula for mth term. Formula for mth term is A plus M minus 1 into difference D upon A plus N minus 1 into difference D. Now D I can write 2A. D can be written as 2A. So A plus M minus 1 into difference can be written as 2A. A plus N minus 1 into difference 2A. A 1 plus 2 is going inside 2M minus 2. Denominator also A I am taking common. So 1 plus 2N minus 2. A to A will get cancelled. It will become 2M minus 1 upon 2N minus 1. This only was the target to prove. So I feel now you are able to understand this question. It is really a wonderful, easy question. Pramit, we have been given Sn is 3n square plus 5n. Listen the question once again. If the sum of n terms of an AP is 3n square plus 5n and its mth term is 164. Its mth term is 164. We have to calculate the value of m. Find the value of m. Listen carefully. If the sum of n terms of an AP is 3n square plus 5n and its mth term is 164, find the value of m. So Sn is 3n square plus 5n. Try to see AP is first term is A, next term will be A plus D, next term will be A plus 2D, and so on. Now S1 is sum of one term is A, and this will be, I'm putting n as 1, so it will be 3 into 1 square plus 5 into 1. So A we are getting as 8. Now S2, that is sum of two terms. These are the two terms. Their sum I need to write. So it will be A plus D. 2A plus D. Now S2 means in place of n we need to put 2. So 3 into 2 square, 5 into 2. So 2A plus D is equals to 3 into 4 plus 5 into 2. A is 8. 2 into 8 plus D equals to D is 6. We have got the value of A and D both. Now C, we have been given AM is equals to 164. AM is equals to 164. AM is A plus M minus 1 into difference D equals to 164. A is 8 plus M minus 1 into difference is 6 equals to 164. 8
plus 6m minus 6 equals to 164. 2 plus 6m equals to 164. 6m is equals to 164 minus 2. 162. Sorry. M is equals to 27. So I think we are able to understand how to calculate the value of M. I've taken maximum possible steps. So still, if you have got confusion, then that is really, see this carefully.